Boys and girls and Cougar parents, today we're going to look at our study guide. I'm just going to go over, model a few problems from each section and give you a little bit of an answer key. Hopefully this will be helpful so that you can check your answers tonight before the big test. Our distance time graphs. Okay, starting here with A, and you have a space on your study guide that provides a brief little description. But if you want to write actually the description of each graph, right on the graph, that makes sense. Here we see a curved line. What we see is we see distance increasing over time, but as you notice, our line starts to flatten out. So what that says is what's happening here is things are slowing down. Okay, so yeah, distance is increasing over time, but you start out fast and you slow down gradually. That's what's happening here because our slope is flattening out. Okay, here in B, we see that we're leaving our starting spot. Okay, so we leave, and then we see this decline, which means we're returning back to our starting spot or home, and then we're leaving again. That's what these up and down, remember? Now, when the steepness of the line says something about the speed or the rate at which you're traveling. But often there's confusion when you see a decline. You think that you're slowing down. That's not the case. Our distance is actually going down. And when distance is going down, that means you're getting closer to your starting point. So for a distance time graph, when you see a decline, that means you're returning to your starting point. Okay, graph C, we see that we're leaving. Okay, and then we have this flat line. Flat line always means there's a stop or a rest. Okay, time is passing, but distance is not increasing. And then we see we're leaving again. Okay, so we're moving away again. Here in graph D, we see a very flat line or a flattish line. So that means we're moving slow. Then my slope picks up a little bit, my incline increases. So that means we're probably going about a medium speed. And this is all relative language. But then we have a very steep line, which means we're moving fast. Okay, so just remember, the steeper the line, the greater your slope, the faster you're moving, or the greater the rate of change. Okay, here in graph E, we see we're leaving. Then we see a stop or a rest up here. That's what the flat line means. And then we return. We actually return to home. We're back to zero. Okay, when our distance is zero, that means we're at our starting point. Here what we see is we see a fast departure. Then we slow down. There's still an incline, but it's very slight. And then we see fast again. Okay, so fast, slow, fast. It's not completely flat. If it was completely flat, it'd be like C over here, but it's not. There's still a gradual increase or an incline, so you just slow down and then you speed back up again. Graph G, we see that we leave, we stop, and then we return again. We've seen this before. Now this is a very interesting one. Graph H, we see that we leave. Okay, our distance is increasing over time. And then what in the world is happening here? Distance is increasing, but time is not. Okay? Distance is increasing, time's not. We're breaking some laws of physics. Unless you're Doctor Who and you just jumped into the TARDIS and you're moving faster than time, okay, because you're moving, but time isn't. You're breaking a law of physics here. This is a mystery here, okay? Somehow you're traveling, but time is not moving forward. Okay, so you must have a time machine, and then we see that we're moving again, and so is time. Okay, so here we leave. This is a mystery here. This is kind of an undefined area of physics. And then we are, again, traveling. We're moving away from our starting point, and time is working again. We see that we leave, we return, and we actually go all the way back home, back to zero, and then we leave, but at a faster rate. Okay, so we're even leaving faster this time. And here we see that we're returning. Okay. Okay, for some reason our initial distance, we were away from our starting point, our origin, 0. But then over time, our distance keeps going down until our distance is 0, which means we're back to our starting point. Okay, so we didn't start at our origin. All very interesting. Okay, let's look at our next part of the study guide. We've got input and output. Here we just have a table. Here are inputs, our x values. They give them to us. Here is your rule, or the function that you're performing on x to get your output, which is y. Here I'm just showing what's actually going in when you substitute -2 for x. For example, -2 goes into x. We take 6 away from that, and we're left with a -8. You can pause and check this. This table down here, we have multiple functions. Okay, what I want to do is walk through each one of these, or at least one sample. And again, you can pause this and check your answers. This is not for copying. If you copy this, you're just wasting your time. This is to check to see if you're doing it right. Okay, we have the function 2x plus 1. I plug in a -3, so I get 2 times a -3 plus 1. Okay, 2 times a -3 is going to be a -6. Okay, and a -6 plus 1 is going to be a -5. Okay, the next one here, I've got 5, and my value for x is going to be a -1 plus 3. So 5 times a -1 is going to be a -5 plus 3 is going to be a -2. And then I move on down to this function here, and I'm going to use the value of 1 for x. I'm going to substitute 1 in. So I have, what is the negative of 1 plus 3? Well, -1 plus 3 is going to equal 2. And now I have this next function, 3x minus 6. So I have 3, and my value for x is going to be 3 minus 6 is equal to, well, 3 times 3 is 9. 9 minus 6 is 3. Then my next function is a -6x plus 5. Okay, my value for x is going to be 4. So I have a -6 times a 4 plus 5. Well, a -6 times 4 is going to be a -24. Okay, and then -24 plus 5 is going to be a -19. If I could draw your attention to my last function down here, my third input, f1, the output of the y value should be -1, not 1. So please look at this again. Now, the next part of our study guide, we have functions, and we're focusing on rate of change. And rate of change is basically slope. Here we have some function tables where we have our time in days and then cost in dollars. And what we do is we use our point-point slope formula, which is the second value of y minus the first value of y, is divided by the second value in x minus the first value in x. What we're really doing is we're finding the difference in the rise over the run, which is the slope. Okay, we're finding the difference between these two values, which is 100 minus 75, and that gives us 25, over the difference in these two values, which is 4 days minus 3 days, which is 1 day. So it turns out to be the rate of change, or the slope, is $25 per day. We do the same thing here. We have a time distance table, and we take, again, just remember that our first column would be our x values, our inputs. The y would be our second column would be our y values, our outputs. We find the difference in our y values, which would represent our rise, and then we find the difference in our run, our x values, and we get 116 over 2. We can simplify that to 58 miles per hour. Okay, boys and girls, let's take a look at number 8. Now I have these answers and work set up for you, but basically what we're doing here, let's take a look at number 8. We'll do 8 together. What we have is we have two sets of, we should say two solution sets here. This would be our first point, which is x1, y1. Okay, negative 7 would be our first x value, and our 2 here would be our first y value. So we have an x and y value of negative 7 and 2. And then our second point, referred to as x2, y2 for our second point. And now we can use our two-point slope formula or point-point slope formula, however you prefer to say it. And the way we do that is we take our y2 minus y1 to find the difference in our rise, and then we take our x2 and our x1, we find the difference of that to find the difference in our run. So I'm going to take y sub 2, which is 1, minus y sub 1, which is 2, and then divide that by my second x value, which is 5, minus my first x value, which is a negative 7. Now 1 minus 2 is going to be a negative 1, and a 5 minus a negative 7 is really a plus 7. That will give me 12, because 5 plus 7 is 12, and that'll give me a slope of negative 1 over 12. What does that mean? 1 down, 12 to the right. 1 down, 12 to the right. It's going to be a negative slope or a decline. Here you go with the next part of the study. Got to have 5 samples here. I have all the work. You're just making a data table, and all you need to find is 2 points, so you can use your 2-point slope formula. You plug in values for x, and you get out your output, which would be y. You subtract your second y value from your first y value, and then you divide that by your second x value minus your first x value. That'll give you your difference in your rise over your difference in your run, which is your slope or rate of change. Let's find the slope from a graph. All you need to do is find 2 points. You want to find 2 points that have clear points of intersection, so you don't have to guess what their x and y values are. But all we're doing is we're taking a look. Okay, when I go from this point to this point, okay, I am dropping 1. Okay, I'm going down 1, so that would be my rise. My rise is actually a fall. It's a negative 1. And then to go from there to there, that would be 3 to the right. So that would be a positive 3. So my rise is a negative 1 since I'm dropping, and then my run is a 3 since I'm going 3 to the right. That's my slope. Okay, now you could find the 2 coordinates for each of these points, then use your 2-point slope formula, but this is a lot quicker. Okay, let's look at our next graph line. I'm going from this point up 3, so my rise is 3. I'm going up 3 plus 3, and then I go 1 to the right, which is plus 1, so that's a 1. So my slope is 3 over 1, or just 3. Let's look at our next graph. This time I'm going from this point to this point. I am going, looks like down 3. My rise is minus 3. That's my rise. And then my run is 2 to the right, so that's a positive. Okay, so my slope is a negative 3, 2. 3 down, 2 to the right. 3 down, 2 to the right. I could extend that line as far as I want with that slope. And for this one here, my rise, it's actually a rise. It looks like I'm going up 1, 2, 3, so it's plus 3. And then my run is 2. So my rise is I go up 3, and then I go 2 to the right, which is a positive 2. Okay, the last part here, what we're doing is we're comparing slopes. And here we have 3 different sets of data, and we have to find the slope of each. For Smith, they give us, this is the price on hamburger, I guess it's dollars per pound. And here we see we have Smith's, we have a data table. From this data table, we use our 2-point slope formula to get our slope, which is 5/4. Over here, we're given a function rule or an equation. We make a data set, use the 2-point slope formula to get the slope of 7/2, which we convert then to 14/4, so we can compare it to 5/4. And then Macy, they gave us a graph. We just found the rise over the run from looking at 2 points on the graph, and we got 2 over 1, but we can see that 14/4 is greater than any of the other 3 slopes, well, 2 slopes. And then number 3, we have an interesting tie. Again, we're given our data, our functions, in 3 different ways. We're given a data table. We use our 2-point slope formula to find our slope. Here we're given a function rule or an equation, and we create a data table and use our 2-point slope formula to get our slope. And we end up getting 3/2 or 6/4 for both of these. And then, last but not least, we're given a graph again. We find the rise over run by looking at 2 different points, and we get 5/4. But Tyler and Aubrey, they tie. Boys and girls, as always, I hope that was helpful, and I'm looking forward to seeing you tomorrow so you can ace that test. See you then. Bye-bye.